We're going to finish our chapter on the sun by talking about the great observatories and probes that have been sent into space to gather more data about the sun. Back in 1995, one of our launches was this solar observatory called SOHO, the Solar and Heliospheric Observatory. This was launched up into space and then pointed towards the sun and always stays pointed towards the sun with a special camera that's got a circular block the right size to block out the photosphere of the sun, and it keeps that thing in place, always pointed in that direction so that the camera's never going to get burned out by pointing directly at the photosphere. That will always be blocked. And so then when it takes photographs of the photos of the sun, it's never going to overexpose the photograph, and you're going to get to see what's going on in the corona of the sun. So this ends up being really good for seeing the effects of solar flares that are bursting on the sun and watching coronal mass ejections that come blasting out of the sun and go off into space. So good for CMEs, coronal mass ejections, huge amounts of plasma that lift off the sun and go roaring out into space. This one has expanded so much, it's as large or larger than the sun itself, which should tell you how big coronal mass ejections can get. SOHO also turns out to be pretty good for finding comets, because in SOHO pictures, you very often would see a little comet that comes streaking along and goes into the sun, or maybe past the sun and on the way out again. Recently, an instrument on SOHO called SWAN has spotted a comet which is becoming visible right now as I'm making this video. It's in the constellation of Cetus. It has just crossed into naked eye visibility, meaning it's about magnitude 5.6. And that means that if you looked at it, it would look like a very faint star or faint smudge in the sky. You're not going to see a comet with a tail yet. Maybe this one has a chance of getting brighter as we go into May, and maybe it will get to the point where you could see a comet with a tail. So I recommend, if you like to see fancy things in the sky, you might want to Google Comet Swan 2020 and watch the development of this comet. See if you get to see one in your lifetime that has a nice tail to it. And don't forget to thank SOHO. Then, in 2010, they launched this, the Solar Dynamics Observatory, the SDO. Now, this has been producing some amazing photographs and some amazing videos, one of which I would like to play in class called Plasma Rain, one of the first ones that came out and showed this filament that was trying to rise up off the surface of the sun and blow out into space as a coronal mass ejection, but it couldn't do it, and it fell back down under the sun like all of the charged plasma raining back down on the sun. It's also a good video for showing the spicules that are always there on the surface of the sun and how their pattern changes over time as they come and go over every 5 minutes. And admittedly, when you look at a photograph like this, with the incredible detail that it has, unlike anything we've seen before for the sun, it almost looks like it's painted or photoshopped or fake or something like that. But these are real. The reason why we're freaking out as to how it looks is because it has such incredible detail like we've never seen before. That's because they planned way ahead to give it the highest resolution possible. This was launched with cameras that could do photographs with 4,000 by 4,000 pixel resolution. And I believe that at the time it was launched, there was no way you could go to the store and even buy a monitor that would show you 4,000 by 4,000 pixel resolution. So they were planning ahead because they knew eventually the technology would catch up so we could see every wonderful detail of all of the pixels of detail that are in these great photographs. I encourage you to go to the website for the Solar Dynamics Observatory and explore a little bit to see lots of the pictures that they have been taking. Finally, this is the most recent thing that has been launched into space to explore the sun, the Parker Solar Probe. This one is a probe. It's not in orbit around the Earth, always taking pictures. It's going to dive in as close as it can to the sun and try to survive a direct encounter with the corona. It ultimately will go only 6 million kilometers above the surface of the sun. Now, if we had any of our other probes that we've ever built try to do that, they would just cook and melt and they would not survive. But this one, of course, is built to survive the heat. That's the whole point. We're going to try and send it into the corona with that mysterious 1 million degree Kelvin temperature and try and gather data to try and figure out the mystery. We want to measure the electric and magnetic fields that are in that corona. We want to count up the electrons and the protons and see how much energy they have as they come blasting out in a solar wind. So this thing was launched in August 2018. It made its first perihelion very quickly after that in November of 2018. And what it did was launch from Earth, start curving in towards the sun, crossing and actually flying past Venus, and then crossing the path of Mercury, and then swinging in for its closest approach. And a closest approach to the sun is called a perihelion. And after that closest approach, it had to swing back out again because with all of that electric field, strong magnetic fields, electrons and protons, it would not be able to send a clear signal through all of that radio noise, and it had to come out here away from the sun to send its information back to Earth. And it comes almost all the way back to Earth before it goes in for another close dive to the sun. The next time is going to be closer, and then the next time after that is going to be closer and closer each time, hoping that it survives so that it can come back out and release its data and send it to the Earth before it goes in closest and closest to try to get that 6 million kilometers above the surface. We look forward to getting more and more data now from our Parker Solar Probe.